Hey guys, welcome to another edition of Geometry. I'm Mr. A, your fearless host, bringing you another lesson. Today we're in section 1.5, and we're going to talk about angle relationships. Okay, so let's see what we're going to try to take care of today. Today, our objectives, we're going to identify and use special pairs of angles, and we're going to identify perpendicular lines. Okay, so that's what we're going to do today. All right, first of all, we've got some special angle pairs that we need to talk about here. So let's go through what they've got here and talk about this. First thing here is, oops, there we go, adjacent angles. Okay, so adjacent angles, as you can see, it says two angles that lie on the same plane, have a common vertex and a common side, but no common interior points. Okay, that's all right here. So let's just kind of see what that looks like. So in this first example here, this is kind of what you see oftentimes. You see several rays that have the same end point, so therefore the same vertex, that's right here, and they share a side. So this side here between angle 1 and angle 2, they have a same side, but they don't have common interior points. So that means that all the points here in angle 2 and all the points in angle 1 are different. So this would be considered adjacent. Basically, adjacent means right next to. It's kind of like your next door neighbors. You're right up, butted up against each other. So same thing here. You notice angle 1 and angle 2, they share this side, but they don't overlap at all. Okay? They give you a couple of non-examples over here. So angle 3 and ABC. Angle 3 is just this angle right here. And ABC is what? ABC is this whole thing. So they do have a side that's in common. They both have a BC. But you notice you could have some points here in between these two lines that they are both inside the angle. So they overlap. In other words, their two angles overlap, okay? And so that would not be adjacent. And then likewise here, angle 3 and ABC. Here's angle 3 and here's angle ABC. They don't even have a common side or a common vertex. So, but yeah, this is the one that can be a little tricky sometimes. People think this might be adjacent because they have the same side, but basically they're overlapping. So this angle here, BC and whatever this point would be, overlaps ABC, okay? Okay, so that's first thing, adjacent angles. Second thing, a linear pair. So in a linear pair, they're adjacent angles. So we just talked about adjacent angles. So they're two angles that share a common side, and the non-common sides are opposite rays. So in other words, it makes a straight line, okay? So if you look at this first example here, angle 1 and angle 2, they share this side, and their other sides make a straight line. So this is what they call a linear pair. Okay, and remember what we talked a little bit about last time is a linear pair will be 180 degrees. Okay, here's a non-example. If you notice ADB, ADB and ADC, they share a common side right here, but their other sides, it's not a straight line. You notice this is bent a little bit here, so this is not a linear pair. Even though they're adjacent, these are adjacent, but they're not a linear pair. Okay? Lastly, the last kind of angle we need to talk about are vertical angles. They are not adjacent, and they're formed by two intersecting lines. So you have to have two straight lines, and the vertical angles are going to just be straight across from each other. So for example, like here, angle 3 and angle 4 are vertical angles. They're right across the V shape, you know, where the two lines intersect. So it makes a V and a V. It's those two lines right across from each other are vertical. So 3 and 4 are vertical to each other. Also 1 and 2 are vertical to each other. The non-example that they give here, you can't say that any of these are vertical angles because why? If you notice, BED is not a straight line. You notice it angles a little bit there. So you cannot call these vertical angles. They can only be vertical if both lines are straight lines. Okay? All right. Let's see what else we got. First example, okay. We want to name two adjacent angles, so angles that are like right up against each other, whose sum means we're going to add them, is less than 90. All right, let's look at our options here. All right, first of all, CAD. So here's CAD, it's 55. DAE. DAE. Are those, first of all, are they adjacent? Yep, they share the same side. Do they add, are they less than 90? Well, 95 and 55, no, that's not less than 90, so it's not that one. What else? It's not that one. FAE. FAE is 30. FAN. FAN. 30 and 55 is, looks like that's 85. Is that less than 90? Hey, it looks like this is it, okay? So you can check the other ones here if you want to, but CAB is this one, 30, and NAB, again, that's these two. They're adjacent, but 30 and 95, nope, that's above 90. And finally, BAD, it's this one right here, and DAC, well, they overlap, so they're not even adjacent angles, so that's not it. So we think it's B, right? All right, let's see what the bouncing magical red circle says. Ah, okay, there it is, it's B. B is correct. All right, example 1B. Name two acute vertical angles. Okay, so first of all, acute means what? Less than 90. And vertical means they're going to be across from each other, you know, when there's two straight lines. All right, BAN. BAN is 95, and EAD, 95. Those are vertical angles. They are straight across from each other, but they are not acute because they're both 95. Okay, not that one. Oh, rats! You saw the answer already. The bouncing magical red ball came in early. Okay, well, you know what it is. So let's just quickly go through here and kind of talk about why these other ones are not. BAD, it's these two together, which is 85, and BAN is 95. Those are not even vertical. They're adjacent, but they're not vertical, so that's why it's not that one. BAC is 30 right here, and CAE, again, those are not even vertical. They're adjacent, but not vertical, so it's not that one. And as you've already seen, FAN is 55, and DAC is 55. So those are vertical. They're across from each other, straight across in straight lines. And so the bouncing red magical circle says yes. Okay. Couple other things we need to talk about then. Angle pair relationships. Okay, so first of all, first thing, really super important. Okay, this is a big thing here. Vertical angles are congruent. This is really important. Remember that. If you didn't notice in our last example, every time we had some vertical angles, they were equal to each other. That's going to happen every time. Okay, so really important on that. That you remember that vertical angles are congruent. So in this case, ABC is congruent to DBE. So angle ABC is congruent to angle DBE. And also these other ones here, ABD, angle ABD is also congruent to CBE. Okay? All right, next, complementary angles. They're not angles that just like to say good things about each other. Oh, that's a nice dress you're wearing. Oh, thank you. No, that's not what it means. Well, they're complementary. Basically, it's two angles that have a measure of 90 degrees. Okay, they add up to be 90 is basically what we're saying here. For complementary, they add up to be 90. And so here's a couple of examples. You notice the drawing they've done here. You've got this big angle here. It's listed as 90 degrees. It's got that square in there that shows it's 90, and this other line has split it up into two parts, and so together these two have to add up to be 90, so they're complementary. These are also adjacent. Remember we talked about adjacent angles? These are also adjacent. But angles do not have to be adjacent to be complementary. Notice these two angles here are not adjacent. They don't have the same side. They don't have this side together touching, but together they do add up to be 90, so they are still complementary even though they're not adjacent. Okay? Then the other thing here is supplementary angles. Okay? So complementary angles add up to be 90. Supplementary angles add up to be 180. Okay? So let's look at a couple of examples again here. Look at angle 3 and angle 4. Remember we talked about a straight line was 180 degrees. So if you have two angles that together that are kind of mushed together like this where they're adjacent and they make a straight line, it's going to be supplementary. But just like complementary, they do not have to be adjacent to each other to be supplementary. All they have to do is add to 180. So here, these two are not right together, but they add up to be 180, so they are also supplementary. So a couple things to remember here. First of all, that if you have a linear pair, remember when you have 3 and 4 here, this is a linear pair. A linear pair is always supplementary. But just because something's supplementary doesn't mean it's a linear pair. Okay? And of course, and I just mentioned this earlier, if it's a linear pair or supplementary, they always add up to be 180 here. Okay? All right, moving on. Example 2a, find the value of x. Okay, so we look at our diagram here. So we say, hey, this is a straight line. These two angles here are right next to each other, and they make a straight line. Well, that means, number one, it's a linear pair. Number two, they're supplementary. Okay, so we're going to write an equation just like we've done before. What do we know? We know that this angle here, 2x plus 3, has to add up with x minus 6 to equal 180. That's the equation that we're going to write. So all we have to do is solve that, and we'll find out what x is. All right, remember, when we're combining two like terms that are on the same side, don't do the opposite thing. You just add them like they are. So 2x plus x is 3x, and then 3 minus 6 is minus 3. And then we just do plus 3. So 3x equals 183. And then we divide by 3. And so, I didn't get out my calculator. I have it available. And so 183 divided by 3 is 61. Okay, so I got 61 there for an answer. Okay, see how that goes? All right, let's take a look at the next example. All right, this is a little bit more complicated, but we're going to use some of the same type of things here. All right, so find the value of x and y. So notice we have an x and a y. So we got to be careful what variables we're using here. All right, so if we look at this, go, hey, before we just had two angles that made a straight line and we could add them up to make 180. Let's do that again. You go, well, what can we do? Well, 3x and 8y minus 102. Oh, wait a minute. That's an x and a y. I can't do that. Oh, there's another one. Let's do that one. 3x and, 2y plus 6. That doesn't work either, does it? Okay, we got to come up with another way to do this. All right, well, the other thing that we can look for here is, remember we talked about vertical angles. Remember vertical angles? All right, vertical angles, they're the angles that are straight across from each other, and they're supposed to be equal, right? So look at 2y plus 6 and 8y minus 102. Hey, guess what? They both have y's, and we know that they have to be equal to each other. So what we can do is 2y plus 6 has to equal 8y minus 102. That's our equation. All right, now we just solve that. So now the 8y and the 2y are on opposite sides, so I'm going to do the opposite thing, minus 2y. And since I got the y's over here, I'm going to do plus 102. So this is going to give me 6y equals 108, and then I'm going to divide by 6. 108 divided by 6 is 18. So it looks like y is 18. Okay, so we got y is 18. All right, great. Okay, we got y is 18. But Mr. Anderson, how do we do the x? There was nothing we could do with the x. We already looked at that. Well, you know what? Now that we got y, what we can do is we can plug y back in over here or here if we want to. But I'm going to do this because 102 is kind of a big number. And I'm scared of big numbers. So that we're going to plug it back into this one right here, right? So 2y plus 6. We're going to plug it into that. So this is 2 times 18 plus 6. Okay. So 2 times 18 is 36 plus 6, which is 42. All right, so this angle right here is 42 degrees. Now that you know that this is 42 degrees, this makes a straight line here, right? So what do we know? We know if we take this angle, 3x, and add it to 42, how much should that equal? What's that? Did you say 180? Good, excellent. So 3x plus 42 should equal 180. So then I'm just going to solve that equation, minus 42. 3x equals, I got 138 there, and divide by 3. So it looks like x should equal 46. Okay? And we could check this if we wanted to. If x is 46, we should be able to do what? 3 times 46? Which is 138. And if I add 138 and 42, does that give me 180? Yeah, it does. So we're good. We got it. Okay? Great. Next one. Perpendicular lines. Okay, so now we're going to talk about perpendicular lines. A couple quick things about perpendicular lines. First of all, they say here, they intersect to form 4 right angles. Okay, so when you have 2 lines that intersect and they've marked, you know, they put the little right angle mark in here, you know that if they mark 1, all of these have to be right angles, okay? So that's a right angle, that's a right angle, and that's a right angle. If one of them is a right angle and 2 lines are crossing, they all have to be right angles. They're also all adjacent to each other. And of course, they're all congruent because they're all 90 as well. And of course, we already talked about this, that symbol telling you that it's a right angle. All right, here's the thing that's new, though, that you haven't seen before. Right here, this kind of upside down T there, that's the symbol for is perpendicular to. Okay, so over here, what we're saying is AD, line AD, this one right here, is perpendicular to CB, that one. Okay, so when you see that symbol, that upside down T, it means it's perpendicular to, and if you look at it, that kind of makes sense because look at these lines, basically they cross and kind of make a T, and just we leave out part of that line there. Okay? All right, well, let's look at an example here. Example 3. Find x and y so that KO and HM are perpendicular. Okay, well, let's see where KO and HM are, first of all. Here's HM. Here's KO. Okay, so they look like they're perpendicular. Looks like 90 degrees, but we have to figure out what values of x and y will make them do that. So let's start. I'm going to start with y this time because y is maybe a little easier to start out with. So here, if this is KO and HM, we want this angle right here to be a right angle, or 90 degrees, right? We want that to be 90. Well, it says it's 3y plus 6, and we want it to be 90, so what's the equation that we can write? Well, we would say, oh, 3y plus 6 would have to equal 90. That's all. And then we just solve that. Minus 6, 3y equals 84, and divide by 3. And then 84 divided by 3 gives me 28. So looks like y is 28. All right, there's our y. Not bad, right? Okay, now let's look at the x's, because what we've got here is we've got a 3x plus 6 and a 9x. But the two of these together are adjacent, they're right next to each other, and together they make up what we want to be 90. So just like before where we made this angle, 3y plus 6 equal 90, this time we're going to make the whole entire thing equal 90, which means we're going to take 3x plus 6 plus 9x has to equal, has to equal 90. There we go. So it's the same concept, but you just have to add two of them together to equal to 90. All right, 9x plus 3x is 12x plus 6 equals 90. Subtract 6. 12x equals, again, 84. And divide by 12 this time. And so it looks like this time x is 7. Okay? So what we're doing is if we get this kind of a problem where we want to find out if it's perpendicular, we just see what would it take to get that angle equal to 90. If it's this here or if it's adding up to, we want it to equal 90. Okay, real quickly here, a couple of quick things just about interpreting diagrams, what you can and cannot assume when you're looking at these diagrams. First of all, if you see a bunch of points like here, you can assume that they're all coplanar. They're all on the same plane, like I said, unless if it's drawn with dotted lines and stuff like that. G, H, and J, you see they're all on the same line. And so you can assume, oh, if they look like they're on the same line, they are. Okay, obviously, you know, M, H, J does not look like it's on the same line, so that's not. You can see all of these rays come together here at point H. So you can assume, yes, that's where they all come together, and one of them doesn't miss by just like a fraction of a centimeter or something. H is between G and J, so if it looks like it's on the same line, it is, and it's in between there. L is in the interior of MHK, so MHK, L, hey, it looks like it's in the middle of that, so it is. G, H, M, and M, H, L are adjacent, so if you see right here, they look like they share that side, so they do. It's not like it's slightly off. GHL is this angle, and LHJ make a linear pair. Again, if this is a straight line and these look like they're adjacent, then this makes a linear pair. And of course, then JHK and KHG, kind of a similar thing there. They're supplementary. That means they also make a linear pair and they're supplementary. What you cannot assume, though, now I think that they might have made a mistake on this thing here, but it says that you can't assume that HM and HL are perpendicular. Well, HM is this one right here, and HL, that doesn't even look like they're perpendicular. So what I would say is, based on this drawing, you might think GH and HL are perpendicular. You can't assume that either, okay? Unless if they put that little square box in there, you cannot assume that just because GH looks like it makes a 90 degree to HL, you can't assume that. You can't assume that JHK, and GHM. Again, these look like they might be the same, but you can't assume unless if they put little arcs in there or tell you the degrees. And really pretty much the same thing with everything else. Any combination of angles or segments, you cannot assume that they're equal to each other unless if they tell you one way or another. Okay, I won't go through all of those. All right, example 4a. Got just a few examples and we're done. We're almost there. Determine whether the following statement can be justified from the figure. So it says, can we, from this figure, tell for sure that VYT, the measure of angle VYT, is 90? All right, well, let's see. VYT. Can we tell for sure from this diagram that it's 90 degrees? It doesn't have a little box in there, but if you notice, you can assume that XYT is a straight line, and guess what? XYV is 90 degrees, so therefore what? VYT has to be 90 as well. Remember, if you have two lines that cross and one of them is 90, then they all have to be 90. So this would have to be 90. So yes, we would be able to justify that. I'm not going to write down the explanation, but you just heard it. Okay, example 4b. How about this? Same diagram. This time it says, can we justify that TYW, that's that angle, and TYU are supplementary? Well, if you look at it again, we can assume that those two angles share the side of YT, and so we can assume that they're adjacent. And because it looks like they make a straight line here, we can assume that that's a straight line, which means, yes, they are supplementary. So we can say, yes, we can justify that. And then last one, what about these? VYW. So here's VYW and TYS. Are they adjacent? VYW is right here. TYS is right here. Do they share a side? It sure doesn't look like it. And so we'd say, no, we cannot say that that would be the case. We cannot justify that one. That is, they would not be considered adjacent angles. Okay, well, that's it. That's all we got for today. A little bit about angles. Appreciate you being here. And I will see you next time when we come back for another lesson in geometry. Talk to you later. Bye.